All right, ladies and gentlemen, welcome back to another video with Mr. Kenton for Physical Science. And today what we're going to be looking at is we're going to look at the introduction to our chemistry unit, specifically with chemical bonding and nomenclature, right? And so in this particular unit, we're going to be building on our understanding of the periodic table, right? In the last unit, we talked about elements, we talked about the type of elements they could be: metals, nonmetals, metalloids. We talked about their properties. We talked about the charges they would form in compounds, all these different things. And so now we're going to take what we learned from that particular unit and we're going to apply it here and start to look at it from the perspective of what goes on when one element bonds or interacts with another element. Okay, and so let's just go ahead. Let's dive right in here. It's going to be a brief intro. Should be really short. So here we go. Now, we need to first start off by defining what is a chemical bond, right? And so for us, we're going to define a chemical bond as a strong attractive force between atoms or ions that are in either a molecule or a compound. Now, to be clear here, what we're saying here is that your atoms, for example, if it's an attractive force between atoms, that's going to correspond to a molecule, right? But if we're dealing with ions, then that's going to correspond to a compound. And like I said, it's a strong attractive force. And this isn't like the idea of liking someone. It's this idea that there are forces that are working together and cause two substances to get closer together. Think of it kind of like a magnet, right? When you have opposite ends of a magnet, they want to get closer to each other. So eventually, like, you bring them close enough, they just move on their own and they come close together. Same thing happens in chemical bonding, right? Now, how do these attractive forces, how are they formed? Like, how does this happen? And it's going to occur in one of two ways, right? The first way is that one element is going to transfer its electrons from itself to another. So you've got it's almost like a transaction. Think of it as, it's one of the elements is bringing something to the table. It's saying, okay, I'm going to give you this. And then the other element is accepting that. And so then there's a change of ownership. So an electron that previously belonged to one element is going to another. So this idea of transferring electrons is the first way. The second way that these attractive forces can be formed between our atoms or ions and our molecules and compounds is through sharing electrons, right? And so here, rather than one element taking complete ownership of an electron, two atoms are going to share the electron between the two of them so that they can be chemically stable. So those are really the two methods by which elements bond, is through transferring and sharing electrons. Now, we do have to make a distinction here. We know that there are what are called core electrons, and then there are valence electrons. And the valence electrons, if you remember, they're in the outermost energy level. Think about Bohr models. They are in that outermost ring. And the valence electrons are going to be the electrons that are involved in determining how atoms combine. So any type of chemical bond that we look at is going to be formed by the fact that valence electrons have either been transferred or shared between two atoms. Okay, just kind of keep that in the back of your mind as we go forward. Now, the next question might be, okay, Mr. Kenton, we understand that there's this idea that elements want to bond. They want to have these strong attractive forces between atoms or between ions. But why? Why is this the case? Why does this happen? And it boils down to this idea of this word stability. And stability is just the idea that something is, I mean, as the word implies, it's stable. It's not easily shaken. It's not easily moved, is another way of thinking about it, right? And for elements, rather than it being some sort of like foundation, like a building where it's stable, it's not shakable, the thing that makes elements stable is having a certain number of electrons, which is going to lead us into the octet rule. Now, the octet rule communicates just this idea that most atoms tend to form chemical bonds so that they can have 8 valence electrons. And again, we probably could have deduced that even from that kind of that prefix oct here, right? Octet rule, referring to 8. So most atoms are going to form bonds in order to have 8 valence electrons. That's going to be the driving force behind either electrons being transferred or electrons being shared between 2 elements. Now this is significant because if you think about it, when we were looking at Bohr models, that for the elements we looked at, the valence energy level, the outer energy level, was full typically when we got to 8 valence electrons. Now there are some subtle nuances to that, like we looked at something like helium, which is okay with 2, or something like boron, which was okay with 6. But the reality is the majority of the elements on the periodic table want to have a filled valence shell. They want to have 8 valence electrons. And this kind of goes to what we learned about in terms of the periodic table, that we have these different groups. The elements want to be like the noble gases, right? And if you remember, that's column 18 on the periodic table. And if you remember, the noble gases, they're unreactive. Why are they unreactive? It's because they have 8 valence electrons. And so for our elements, 8 is really good, right? And we even see here, there's the Lewis dot diagram for neon. We show those 8 dots representing its 8 valence electrons. And so to summarize this particular slide, ladies and gentlemen, stability is going to be the driving force behind bond formation. At any time a substance or an element is going to react with another substance is because it's trying to become more chemically stable. And the last thing I want us to take a look at as we go into looking at the first type of bonding is our understanding of ions. This was a word that we defined a couple units back, and we talked about how ions were atoms, elements, that had either lost or gained electrons in order to become electrically charged. And so I've listed several examples here. You know, for example, we should have remembered that our metals are the elements that tend to lose electrons. So if you look here at sodium and magnesium, both of those have a positive charge, sodium +1, magnesium +2, showing that they lose electrons in order to become stable. Whereas if we look at our chlorine and oxygen, we can see here that chlorine and oxygen, they both have a negative charge, right? Chlorine at -1, oxygen at -2. So that means that chlorine and oxygen gained electrons respectively. And one last vocabulary term, remember, for your positively charged ions like sodium and magnesium, they form what are called cations. So positively charged ions are cations, and then our negatively charged ions like chlorine and oxygen here would be considered, if you remember, anions. So those are negatively charged ions. All right. And that, ladies and gentlemen, is our introduction to chemical bonding. All right. So make sure you watch this video, take notes here, look over the information that we've even gone over previously, because you're going to need that as we're moving forward. So thank you for taking the time to watch this video, and I look forward to seeing you guys in class again soon. Take care.